So this lesson, we're going to be comparing different types of functions, models, graphs. So we've learned quite a few different types of graphs. We learned the linear, which is a line. It looks like a line, like so. We've learned exponential functions, which are curves, like so. We've learned parabolas, which are quadratics, which are a parabola, which is a U shape. Rational functions, which is called a hyperbola, which remember it's like kind of like the C's, I guess. Absolute value we just learned, which is our V shape. And our polynomials has a variety of different shapes. However, they have like the number of curves is one less than their exponent. So an example of that would be like this. This would have an exponent of 3 because it has 2 terms. So basically what we're going to be doing is looking at these either at a graph, so we're going to plot ordered pairs on a graph and see what type of shape it has. Or we're going to be looking at an equation and determining what type of model it is. Okay? I would have drawn those shapes if I was you. If you didn't already do that. All right. So when it comes to ordered pairs, we're going to plot the ordered pairs on a graph and determine the shape. So if it's a U, then it's a parabola or a quadratic. If it's a line, it's a linear. If it's, curve, then it's exponential, and so on and so forth. Okay. So our first ordered pair is at -3, 4. Then at -2, 2. -1, 1. 0, 1/2. 1, 1/4. 2, 1/8. And 3, 1/16. This is a curve shape, so this would make this what type of problem? Okay, exponential. What type of model? Exponential. All right, so now we're going to look at the next one. Okay, so at -3, I'm at 4. At -2, I'm at 7/2, which is 3.5. At -1, I'm at 3. At 0, I'm at 2.5. At 1, I'm at 2. At 2, I'm at 3/2, which is 1.5. And at 3, I'm at 1. Other than my graph probably not being on graph paper, so that makes it not exactly the prettiest. What type of model is that? It's a line, so it makes it linear. So plot the points, figure out the shape. Pretty easy. Determining from an equation, we need to make sure the equation is in the form of y equals, because if you look at our chart, all of our equations are in the y equals format. Then you look to see which one it matches. If it has an x, a variable in the exponent, like x, then it's going to have to be exponential. If it has absolute values, it's going to have to be absolute values. The other ones are the ones like, well, it's y equals x plus b, it's linear. The other ones are the ones where you're going to have to look at for sure, okay? Figure out which type it is. Okay, so our first one here, it's not in the form of y equals. I need to get my y by itself, so I'm going to subtract 3. I'm going to get y equals x squared plus 6x minus 3. So this is an ABC format, so that's going to be a quadratic, which a quadratic is a type of polynomial, but it's the more precise word of it, so it's a quadratic. Ax squared plus bx equals c, or minus c plus c. Alright. This one has an absolute value. So anytime it has an absolute value, it's going to be an absolute value. Okay, there's nothing about it. Okay. Alright, we have a variable in the exponent. So this would make this a exponential. Anytime you have a variable in the exponent, it's going to be exponential. Okay, this isn't in the correct format, so I need to subtract 2x and get y equals negative 2x plus 1. So this is in y equals mx plus c, which makes it linear. Okay. So that is determining what type of model it is. Now we're going to actually be comparing two different types of models. So they're going to ask for you to identify a key feature, like slope, y-intercept, maximum or minimum value. That's probably really about it. You are going to then, once you've figured out what that key feature is, like if you're finding slope, you have to do y2 minus y1 over x2 minus x1. I know that a lot of these equations don't have an exact slope, so they're going to be in an interval. Okay, so it's going to tell you which values to use. Your answer is going to be based on that information. It's either going to tell you which one is greater or less or higher or lower or whatever. Okay, it's kind of hard to explain because they could ask you for anything. Ask you what the which has a greater y value, y-intercept, which has a lower y-intercept, which one has a larger maximum or minimum, which one has a smaller maximum or minimum, which one has a larger slope or a smaller slope, just different things that they could ask you. So our first one, though, is asking us for the greater, so we're looking for larger, rate of change, so slope, with the interval from 5 to 10. So we're only looking at the values of 5 and 10, okay? So, my first equation here, we're going to have to create a chart and then find our slope. Okay, so I need to find my x and y values for 5 and 10. So 5 and 10 are going to be my x's. So 5 and 10. We have x squared plus 4. We need to find our y values so that we can find our slope. So I'm going to do 5 squared plus 4, which would be 29, and 10 squared plus 4, which would be 104. Now I can find my slope by doing my change in y. So 104 minus 29 over 10 minus 5, which will be 75 over 5, which my m then would be 15. Okay, so that's my m for that one. Now we need to find my m for the other one, okay, because we're comparing the two from 5 to 10. Okay, so I'm going to be looking at my 10. 10 minus 777.5 over 10 minus 5, which will be 232.5 over 5, which is 46.5. Okay, now that we found our two m's, Which one has a greater rate of change, A or B? B. B is 46.5. A is 15. Which one's greater? 46.5, obviously. And so B would be my answer. They could have asked us for which one has a larger y-intercept, okay? And what is our x value on our y-intercept? What's the x value on the y-intercept? What is the x value? It's the same for every equation. Okay. Let's think on a graph. What's the x value here? What's the x value here? 0. 0. So my y-intercept here would be 300. And to find the y-intercept for this one, I would substitute in 0, and it would be 4. So which one, if we were looking for greater, it would obviously still be B. But if you were looking for smaller y-intercept, then it would be A. That's just a type of, that could be a problem if they ask. I don't know, I'm just saying, okay? So you gotta keep in mind what they're looking for. For the next one, it's asking which one has a larger, you're looking for larger, minimum value. So that's gonna be my y value of my vertex, okay? And what, B is easy for us to find right now, so let's look at that. What would be my y value here of my minimum point? -4. Okay, y equals -4. Okay, that would be my minimum value. So I need to find my minimum value of this quadratic here. So I need to find my vertex. Does anybody remember how to find the x value of your vertex? It's -b over 2a. You have to remember this stuff. So we're going to do -6 over 2 times 1, which would be 6 over 2, which is 3. So that's my x value. I'm looking for my y value. So what do I have to do then? Substitute it back in. Y equals 3 squared minus 6 times 3 plus 1. So that's going to be y equals 9 minus 18 plus 1. So y equals -8. So what? Which one is larger, -4 or -8? -4. So my B would have a larger minimum point. Okay? It could have asked for a smaller minimum point. It could ask for, this could have been a absolute value equation. Because absolute value also has a vertex. Okay? So you got to keep that in mind, what type of problem it is. It could have also asked for your y-intercept, and you had to find the y-intercept. There's a lot of different things it could ask for. Which your y-intercept here would be 1, and the y-intercept here is -3. So this one would have a larger y-intercept. You got to keep that in mind. Okay?